This is a new category of compound naming. We're going to deal with something called covalent compounds. And in covalent compounds, electrons are shared. But what we need to know in a covalent compound is that a covalent compound is formed between two nonmetals. Two nonmetals. Tell me, what's the charge of a nonmetal? No. On your periodic table, where do the nonmetals come? They're on the right-hand side, so they're all negatives. So if this is a formation of two atoms that have negative charges, is there any way we're going to get to a neutral compound? No. So when we see this, these are both anions. And so that means for these compounds, charge does not matter. Okay, the charge does not matter because it's two anions. There's no way that I would get to a neutral. If I'm trying to put two negatives together, it's not going to happen. So it's formed between two nonmetals, which are both anions, which means we are not concerned with the charge. Okay, which means we don't ever have to do a crisscross mode or anything like that, right? There's nothing like that's going to happen. All right, in our compound, the first element in the formula is named first using the full element name. Okay, so let's give an example of a covalent compound. This right here is a covalent compound. So is this one. Do we know what these are called? What's this one called? CO2. What's the name of it? Carbon dioxide. And what's the name of this one? Carbon monoxide. Do you notice it's not called carbide dioxide or carbide monoxide? It's called carbon monoxide. So the first element in the formula is named first, giving the full element name. That's really important. If you ever have trouble thinking about the covalent rules, just remember carbon dioxide, right? It gives you the rules right there. The first element keeps its regular name. The second element is named as if it were an anion, which means it ends in IDE. Carbon dioxide, not dioxygen. Carbon dioxide. Okay, the second element always gets a prefix. Okay, do you know what I mean when I say prefix? What do I mean by that? Where do prefixes come? Before the word. And in this case, the prefixes I'm talking about are mono, di, tri, right? It tells us how many of that element there are. I'll give you that chart here in just a second. But the second element always gets a prefix. The first element only gets a prefix if there is more than one of the element. If there is more than one of the element, it gets a prefix. So let's again go back to our example. We don't call this monocarbon dioxide. We call it carbon dioxide. But the second one does get a prefix no matter what. Carbon monoxide, right? Mono means one. So there's our rules for covalent naming. Do I have the chart for you in your notes? Is it in there?
It's in there. Yes.
Okay, good. So here is our table of prefixes. Mono, di, tri. Here, was there any that stand out to you? Tetra might be different. What do we usually think of when we think of four? Quad. We usually think of quad, but tetra means four, and then the rest are really all ones that we know. Okay? Okay, very good. Go ahead and try some covalent compounds here. The good thing about covalent naming is that there's no crisscross. There's no concern with charges. We just have to read it exactly as it's written. Okay, covalent compounds. Let's try this one. Silicon dioxide. So our formula would be SiO2. We don't have to crisscross. We don't have to worry about charges. We're just writing it exactly as it's written. So covalent naming is significantly easier than ionic naming. Now, let me ask you this. Do we ever use prefixes in ionic compounds? The ones we just finished. Nope, we don't use prefixes at all in ionic compounds. All the ones we just practiced with our game, did we ever use a prefix? Nope, sorry, nope. With the ones we played our game with, our ionic compounds, we never use a prefix. We only use them for covalent compounds. How can I tell if a compound is ionic or covalent? If I just look at, if I see this formula and I have to decide, how do I name it? How do I decide if it's ionic or covalent?
Both anions?
It's right. Are they both anions or are they a metal and a non-metal? Okay, because that's the first decision you have to make. When you're given a whole sheet of compounds you have to name, the first thing you have to decide is it ionic or is it covalent? Because you have a certain set of rules for how to name them. Okay? So let's say that I have this compound, S4N4. S4N4. What's the prefix for 4? Tetra. And does sulfur here get a prefix? It does, because there's more than one sulfur. The rule is it gets a prefix if there is more than one of it. So it would be tetra sulfur tetra nitride, right? And it ends in NDE. Tetra sulfur tetranitride. Are we in agreement there? Do we see how that works?
Yeah.
Okay. I'm going to give you a couple other little spelling rules here and speaking rules for using these, okay? The rule is if the element begins with a vowel, drop the A or O, from the prefix. Okay, so let me give you an example of that. If the element begins with a vowel, we drop the A or the O from the prefix. So let's look at that again. Let's look at CO2. Carbon, we don't call this one monooxide. We call it monoxide. You see the difference? We wouldn't call it tetraoxide, we call it tetroxide. We drop the ending off that prefix for it to just sound a little bit smoother in our element name. Okay, so if the element begins with a vowel, we drop the O and the A. That's not something I'd probably count off for. It's just really how you're supposed to do it. Okay, so if it starts with a vowel, we drop the A. That does not apply to I's. So if we have a formula that looks like this, P2I3, let's go ahead and name this one, P2I3. What would we call it? Di what? Diphosphorus. Not phosphide, diphosphorus, then what? Yeah, this one, it doesn't apply to I's, so we actually keep both. Triiodide. Okay, it's a little funny. And just like if it was O3, we would call it trioxide, not troxide. Okay, so it doesn't apply to the I. Diphosphorus triiodide.
Is there a reason you don't drop the I?
I think it's just a speech rule, right? It's just what sounds most appropriate, but I don't know the reason for that. Okay, tell me what other questions we have. Yep. Yep. All right, so let's give Si3O2. Okay, what is it? Good. Trisilicon dioxide. Trisilicon dioxide. Good, very good. Okay, what if I asked you to go from the name to the formula? So, tricarbon tetrachloride. Tricarbon tetrachloride. So we write it exactly as it's written, no crisscross. Okay, tricarbon tetrachloride. So it would be what? C3, Cl4. Good. C3Cl4. Okay, yeah.
Do the noble gases ever make a...
They can. Yep, they can. It typically happens with the noble gases. Like below argon, they have a little bit more room because they have more shells, so they're able to bond, and they'll do it a little bit more often, but they can. We would name them just like normal. One thing about covalent compounds, they are non-reduced. You're not going to reduce a covalent compound. So if we see C2O2, we're not going to reduce that down to be CO, though they behave differently. Ionic compounds always reduce themselves down to the smallest version, but since they share electrons, they're not trading electrons, since they share, they have lots of different ways they can go together, and so they will not be reduced. Okay? All right, let's do a mixture of practice here. So I'm going to give you compounds that are either ionic or covalent. So you have to decide first, is it ionic or covalent? And then that'll tell you which way you need to name them. So right now I'm going to give you all formulas. You're going to give me written names, and then we'll do some of the other ones. So let's see. The first one is going to be this. I'm going to give you 3 of them here. Okay, there are 3 formulas. I want you to give me the written name for all 3 of those. So if we look at ICl, do we think that is ionic or covalent? Just tell me that. Is it ionic or covalent? It is covalent. Do we have a name for it? Iodine. Do we make sure to put an INE on the end?
Yeah.
Iodine, and then what? Monochloride. The second element has to have a prefix all the time. Every time it has to have a prefix. Did we remember that? Some of us, yeah, some of us did. The second one gets a prefix no matter what. Prefix, no matter what. All right, how about the next one? CO2S3. Is it ionic or covalent? It's ionic. How do we know? Right, because it has a metal, right? It has a metal. That automatically tells me that it is ionic. And so the name of it would be
Cobalt-3 sulfide.
Cobalt-3. Good. And then what'd you tell me the ending was here? Sulfide. Good, I agree. Cobalt-3 sulfide. Good. Did we get the Roman numeral correct there? Or do we need to go over how we got that answer? Okay. How about our last one, Na2CO3? Now, answer this question for me first. How do I know that this one and this one are different? How can I tell that this is cobalt and this is not? Right? Did you pick up on that? This one is cobalt and this one is not cobalt. 2 capital letters tells me this is C and then big O. Right? This is C then little o.
I didn't even notice that. I just like it didn't make sense whenever I just was trying to do it.
Uh-huh.
Yeah, same.
Yep, this is C little o, so that's cobalt. C big O would mean carbon, oxygen. I didn't do a very good job making that one look little, but this is CO3, so carbon and then 3 oxygen. So do we have a name for this second one? First of all, is it ionic or covalent?
Ionic.
It is ionic. And then do we have a name?
Sodium carbonate.
Good, sodium carbonate. Carbonate comes from the box, right? When we see a compound like that, we've got to check the box for it. Okay, so it's sodium carbonate. Do we need a Roman numeral on that one? We don't, because sodium does not require a Roman numeral. Okay. All right, let's try somewhere we go. I give you the name and you give me the formula. Okay. Let's see. I give you the name. You give me the formula.
This is PO4, this is 2.
I agree. Perfect. Okay. Phosphate is PO4 minus 3. Iron is plus 2. So we're going to crisscross that. And I think we get that right there. Okay. Can we reduce these ones? No, we're never gonna touch that 4 that's right there. That's part of phosphate's identity. All right, sodium oxalate. Darren, what'd you have?
I didn't get to that one.
Okay. Ryan, what'd you have?
I had, I don't know if I did it right, but I
Okay.
had Na2, and then, C2O4.
I agree. Just like that. Sodium is a +1 and oxalate is a -2. Do we need to put parentheses if there's just one of our polyatomic ion? We don't, right? Only if there's more than one. So we leave it just like that. Very good. And then our last one, sorry, we didn't really identify first. Were these first two ionic or covalent? They were both ionic. Our last one here, though, is what?
Covalent.
It is covalent because it has a prefix, right? That's the first hint for us, but it's between two non-metals. What about this one? Peter, did you have a guess on this one?
Yeah, I said NCl3.
NCl3, I would agree. Okay. Tell me what questions we have about our mixed naming here. Yeah, go ahead,
The
Brandon.
last one, why wouldn't we put N3?
Yep, we don't have to do any sort of crisscross. Nitrogen, if there was supposed to be 3 nitrogens, it would be called trinitrogen,
Oh,
right? But it's not. So it's just nitrogen. And if that's the case, we assume that, you know, there would be a single prefix on the front of that. Okay. Peter, did you have a question on that too?
Yeah.
Uh-huh.
For both ionic and covalent compounds, we
Yep.
only have 2 ions, right? Not
That's right.
3 or 4.
That's right. Right. We're not going to be adding a whole bunch of extra names to it, right? That'll be kind of where we sit. Yep. Good question. Okay.